Hello aspirants, welcome back to our channel Food Tech Online. Hope you all are doing good. So our first question is, which of the following is an oil soluble pigment which is present in fruits and vegetables? So over here our correct option is option number B, that is carotenoids. So carotenoids, these are the natural pigments which are found in fruits and vegetables, and they give them yellow, orange, red colors. So basically examples we can say like carrots, pumpkins, mangoes, papayas, whereas these flavonoids, anthocyanins and tannins, they are water soluble pigments, and only this carotenoid over here is oil soluble, or we can say it is a fat soluble pigment. So these tannins, they're basically found in some teas, some fruits. Even they give them some astringent flavors, taste. Whereas anthocyanins, they give red, purple, blue colors. Example like berries or the grapes. And flavonoids, they are found in some citrus fruits in teas. So over here, my correct option is option number B, that is carotenoids. Question 2. Which of the following represents the group of saturated fatty acids? So, saturated fatty acids, they are basically the fatty acids without any double bonds between the carbon atoms. So, they are usually solid at the room temperature. Am I right? Saturated fatty acids, they are without double bonds, and usually they are solid at room temperature. So over here my lauric acid, so lauric, it is C12 is to 0, so it is saturated. Myristic, it is C14 is to 0, and arachidic, it is C20 is to 0. So hence all have no double bonds. Hence this is a saturated fatty acid. So A is my correct option. Whereas now palmitic. So palmitic, linoleic and linolenic. Whereas this linolenic, so it is a 3 bond. In linolenic, 3 double bonds are present. So hence it is a polyunsaturated fatty acids. Linoleic, in these 2 double bonds are present. So it is also a polyunsaturated fatty acids. Whereas over here oleic, so this oleic, it is a monounsaturated fatty acid, means only one double bond is present in this. And in option number D, behenic, caprilic and arachidonic. So arachidonic, again it has 4 double bonds, so it is a polyunsaturated. So hence we know that saturated fatty acids, they are fully packed with hydrogen. So over here no double bonds are present. Whereas in this option number A is my correct option. Question number 3. The anti-nutritional factor which is present in fava bean is, so another name of fava bean is broad bean. Just remember this. So the correct option will be option number C, that is vicine. So this vicine, it is an anti-nutritional compound which is naturally found in these broad beans or the fava beans, and it is toxic to the individuals with glucose 6 phosphate dehydrogenase deficiency. What happens to them? Like this vicine and its correlated compound, that is convicine, they can cause a condition that is favism, which will lead to a hemolytic anemia. This means the breakdown of RBCs. Whereas this gossypol, it is an anti-nutritional compound which is basically found in the cotton seeds. Curcusin, so curcusin basically it is found in Gerothfa curcus. And cyanogens, basically this is found in cassavas or any cyanogenic plants. Question 4. Thiarubicins and thiaflavins in black tea are formed by the formation and dimerization of quercetin, catechins, gallic acids or campherols. Now over here my correct option will be option number B, that is catechin. This thiarubicins and thiaflavins, these are the key pigments which is responsible for color, flavor, uh, even it will give some astringent taste to the black tea. Now they are formed during the means this black tea, it is formed during the fermentation, or better to say oxidation process. We have read this. Now this catechin, which is a natural polyphenol which is present in the black tea, it will react with the oxygen. Hence now this oxidized catechin, it will combine to form this thiarubins and thiaflavins. Thiaflavins, it will give some yellow orange, it will contribute to them to some briskiness to the tea. Whereas this thiarubins, it will contribute to some red to brown, and it will add some depth to the tea. Catechins, say for example apicalocatechins or epicatechins, these are the primary substrates for these reactions. So option number B is my correct option over here. Question 5. Which of the following enzymes sequentially releases maltose from starch? Alpha amylase, beta amylase, glucoamylase or pullulanase. So maltose, it is a disaccharide, and the enzyme that sequentially releases maltose is the beta amylase, that is option number B. Since it will cleave the alpha 1,4 glycosidic bonds, to form a non-reducing end of the starch, and that is the maltose unit. Whereas alpha amylase, it will break the starch randomly into the dextrins. And glucoamylase, it will release the glucose, not the maltose. And pulinase, it will debranch the starch by attacking, it will debranch by attacking alpha 1,6 glycosidic bond. So over here my correct option is option number B, that is beta amylase. Question number 6. Red dog is one of the byproducts during milling of corn, rice, ragi or wheat. So over here my correct option will be option number D, that is wheat. So this red dog is a byproduct of wheat milling, specifically during the production of flour. Basically, it consists of fine bran particles, germ residues, and the endosperm regions, which is left after the flour extraction. Hence, it is named red because for its reddish brown color, which is because of the bran pigments and its coarse texture. And it is mainly used for the animal feed. So over here, my correct option is D, that is wheat. Question number 7. Which one of the following compounds is present in soybean and it acts as a phytoestrogen? Tangeritin, lutein, quercetin or genistein? So correct option is D, that is genistein. So this genistein, it is a phytoestrogen. Actually, it is a plant-derived estrogen compound which is abundant in soybean. And it belongs to the isoflavone classes, which basically mimics the estrogen by binding to its receptor. Whereas tangeritin, it is basically found in the citrus flavonoids. Lutein, it's a carotenoid. Basically for eye health pigment, and it is not a phytoestrogen. And quercetin, it is a flavonoid with antioxidant property. So over here my correct option is D, that is genistein. Question number 8. Which one of the following is an oligosaccharide? So what is an oligosaccharide? Oligosaccharides are the chains of consisting of 3 to 10 monosaccharide units which are linked by the glycosidic bonds. These are actually the short chains. Options are xanthine, alginate, raffinose or gellan. So over here my correct option is C, that is raffinose. So basically raffinose, it is a trisaccharide Trisaccharide means 3 units. What are the 3 units? Galactose, glucose and fructose. So they will make these 3 will make a oligosaccharide, that is a trisaccharide. Basically, these are found in beans, cabbage, whole grains. Whereas the xanthan, it is a polysaccharide. Alginate is also a polysaccharide, and gelatin, it is also a polysaccharide. So over here my correct option is option number C, that is raffinose. Question number 9, we have to identify the gas composition in percentage which is suitable for packaging cured meat under modified atmospheric packaging conditions. So under MAP conditions, we need 0% of oxygen. We need 0% of oxygen because it prevents oxidation, discoloration of the cured meat. Next, carbon dioxide percentage should be there because this will help in inhibition of the microbial growths. Nitrogen gas will be there since it will actually act as a filler gas to maintain the space in the uh, package product. So over here, my correct option, that is option number A, oxygen is 0, then carbon dioxide is 50, nitrogen is 50. So my correct option will be option number A. Question number 10, we have to choose the correct statement about the enzyme and its application in the food processing reaction. So first one, that is chymosin. It is widely used in cheese manufacturing. Chymosin means rennin. So it is widely used in cheese manufacturing industries. So this is true since this chymosin, it coagulates the milk protein, that is the casein. Next, thermolysin is used in the synthesis of aspartame. So this is also true since this thermolysin, it catalyzes the peptide bonds. So, formation, and it is used industrially to make the artificial sweeteners like the aspartame. So this is also true. Next, beta galactosidase catalyzes the hydrolysis of galactose. So this is not correct since beta galactosidase hydrolyzes lactose to glucose and galactose. So it hydrolyzes lactose to glucose and galactose. So this is not true. Next, lipase is used for restructuring of acyl glycerol. So this is also true since lipase, it is used in esterification of fats and oils. So it changes the structure of the triglycerides. So over here correct option is A, B and D. So question number 11, which of the following is not a caramel flavor producing compound? So first we need to know what are caramel flavor compounds. So caramel flavor compounds, they are basically formed during the caramelization of the sugars, and it mainly produces the furan and the pyran derivatives. So these compounds, they give the sweet caramel or a say burnt sugar like aromas. So over here option number A, that is 3-hydroxy 2-methyl-pyran 4-one, so it is a pyran compound. It is known for strong caramel aroma, common in heated sugar systems. So option number A is correct. Next, 2H4-hydroxy 5-methylfuran 3-one. So it is a furan group. So the classic caramel like flavor compound, and it formed during the sugar heating. So this is also true. Next option number C, that is hydroxy 2-acetylfuran. So again it is a furan derivative. So it contributes to the caramel and roasted notes. So this is also correct. But option number D, that is para-amino benzoic acid. So it is actually uh, aromatic amino acid derivative and not a caramel flavor compound. So it do not form during the caramelization, and commonly it is known for vitamin related and chemical uses and does not contribute to the caramel flavor. So over here my correct option will be option number D, that is over here they have asked not a caramel compound, so option number D will be my correct option. Question number 12. Which one of the following statement is incorrect with respect to the controlled atmospheric package and modified atmosphere package of agro produce? CAP and MAP limit microbial as well as biochemical activities. Gas composition inside a MAP during the storage is continuously monitored and regulated. CAP implies a greater degree of precision than MAP in maintaining specific levels of gas composition. Modification of the atmosphere inside a MAP is achieved by natural interplay between the respiration of products and permeation of gases through the packaging film. So, controlled atmospheric packaging and the modified atmospheric packaging, they are used to extend the shelf life of the food product. By just altering the gas compositions like oxygen, carbon dioxide, nitrogen. So over here my incorrect statement is option number B, that is gas composition inside a modified atmosphere packaging during the storage is continuously monitored and regulated. So it is not monitored, it is not continuously monitored or regulated. The gas levels are set initially and change passively due to respiration or the permeation. Whereas this controlled atmospheric package, it will however actively control and it will maintain the precise gas levels throughout the storage. Whereas other options, so option number B is my incorrect statement, whereas other option, that is both CAP and MAP, they will slow down the growth and the biochemical reactions. Yes, this is true. And CAP is more precise than MAP in the gas regulation. This is also true. And MAP, it will rely on produce respiration and film the permeability to modify the atmosphere. So my correct option is option number B. And comparing the CAP and MAP, we can say that CAP is high cost, which is used for long-term storage, and whereas MAP, it is cost effective but short-term. The ratio is defined as percentage of absorbed nitrogen retained in the body, weight gain in body mass in grams per gram, protein intake, ratio of essential non-essential amino acids in the protein, or percentage in vitro digestibility of the protein. So protein efficiency ratio, actually it is a measure of how effectively a protein it supports the growth. For example, basically these are studied in the animals. So protein efficiency ratio, it is weight in weight gain in gram by protein intake in gram. So over here my correct option is B, that is weight gain in body mass in gram per gram protein intake. So a protein efficiency ratio, basically it focuses on weight gain per grams of the protein which is consumed, not on the nitrogen balance or the amino acid residues. And this option number A, that is percentage of absorbed nitrogen which is retained in the body, it basically describes the net protein utilization, that is NPU. And option number C, that is ratio of essential and non-essential amino acid in the protein. It basically refers to the amino acid consumptions, not compositions, not the protein efficiency ratio. And option number D, it describes about the protein digestibility, which is that is in vitro digestibility of a protein. So over here my correct option is option number B. Question number 14. Which of the following are correct pair of GRAS, chemical food preservative, affected organisms and given food matrix? It is an MSQ type question. So GRAS, it stands for generally recognized as safe. So preservatives which are approved for use in specific foods to target particular microorganisms. So sodium lactate, bacteria, pre-cooked meat. So this is correct. Since sodium lactate, it will inhibit the bacteria. Say for example, Listeria. Which is present in the processed meat. So this is correct. Next, caprylic acid, insects, cheese. So caprylic acid, it will target basically the molds, or say yeasts, not the insect, which is used in cheese clotting, not wraps. This is not correct. Dehydroacetic acid, molds, squash. So dehydroacetic acid is used against molds, but it is not used in squash. It is commonly used in um, baked goods, cheese and all. Sodium nitrite, Clostridia, mute curing preparations. So sodium nitrite, it will prevent the Clostridium botulinum, a bacteria which will grow in the cured meats, say bacon or the ham. So this is also correct. So over here my correct option is option number A and option number B. Question number 15. Choose the correct pair of pigment and their corresponding color in plant products. Carotene, yellow, orange, pepper. Betanin, purple, red, cactus, pear. Lycopene, red beets. Flavonols, orange, red, cauliflower. So first of all, this betanin. It is a beta-cyanine pigment which is responsible for the vibrant red or the purple color present in cactus, pear, optinias and other beets. So this is my correct option, option number B. Option number A, that is carotene, yellow, orange, peppers. So this is also correct. It's carotenoids, for example, beta carotene. Are correct for yellow orange hues, and these are dominant in carrots, pumpkins, peppers. So this is also correct. Whereas lycopene, red beets. So lycopene, it is a red pigment. It is basically present in tomatoes. And option number D, that is flavonols, orange, red, cauliflowers. So flavonols, these are colorless. So this also becomes incorrect. So over here my correct option is option number A and option number B. So high, this betanins, it's actually a pH sensitive means the color will shift in acidic as well as in alkaline conditions. And this carotenoids, that is lycopenes or the beta carotene, these are lipid soluble, these are heat stable, whereas beta-alanines, which is present in betaine, it is a water soluble and it is heat sensitive. And anthocyanins we have read, that means the flavonoids. It is a pH dependent and it is red in acidic condition and blue in alkali conditions. Now question number 16. Out of the 7 principles of the HACCP system, 4 are being listed over here. We have to arrange these principles in order in which they are being applied. So in class we read the mnemonic, that is of HACCP 7 principle. So HACCP, it stands for hazard analysis and critical control point. Now the 7 principles mnemonic is: how can little monkey catch very rare? H, it stands for hazard analysis. C, it stands for critical control points. L means critical limits. M, monitoring procedures. C, corrective actions. V, verification procedures. And R, record keepings and the documentations. So these are the mnemonics for the 7 principles of HACCP. Now over here, first one, that is conduct a hazard analysis, means we'll identify the potential biological, chemical or the physical hazards. Next we'll establish the critical limits. So this is first, this is second, that means we'll set the maximum or the minimum values to ensure the safety, like temperatures or pH. Then we will establish the monitoring procedures. So we'll decide how to observe and record the critical limits which are being met. And at last we'll establish the record keeping and documentation procedure. So over here my correct option will be option number A, that is PQPRQS. Of milk casein is because of the highly hydrated carbohydrate residues in options alpha S1 casein, alpha S2 casein, beta casein or kappa casein. So over here my correct option will be option number D, that is kappa casein. Actually this colloidal stability over here, it refers to the ability of the milk protein, that means the caseins, to remain dispersed in the milk without clumping or precipitating. Now this kappa casein, it will play a key role over here in the stability. Because it has highly hydrated carbohydrate residues first of all, uh, or else we can say it as glycosylated, which is attached to a structure. Now these carbohydrate groups, it will form a hairy like layers on the surface of the micelles, which will prevent them from sticking together. Now if this kappa casein will not be there, what will happen? It would aggregate, and it will aggregate because of the hydrophobic interactions. So these kappa casein, actually it prevents them from this aggregations. Okay, and this alpha S1 casein, alpha S2 and beta caseins, these are actually hydrophobic, but they lack the carbohydrate residues. So they basically contribute to the micelle structures, but they do not provide the stability. Whereas this kappa casein, it will provide the stability. So over here correct option is D, that is kappa casein. commonly used as a preservative in the tomato sauce: sodium sulfite, potassium sorbate, potassium sulfite, or sodium benzoate. So tomato sauce, we know it has high water activity. High water activity means it's more prone to microorganisms. Now we have to add preservative to extend its shelf life or inhibit these microorganisms. So basically we add sodium benzoate. Since sodium benzoate is commonly used preservative, it's a common preservative for acidic foods. Now tomato sauce, we know it's an acidic food like ketchup, fruit jams, sauces. These are acidic foods. Now, it works best at pH less than 4.5, means where it will convert to benzoic acid and it will activate the antimicrobial forms. And this tomato sauce, naturally it has pH say around 4.2 approx. So sodium benzoate, it is very effective in this. Whereas this sodium sulfite, potassium sulfites, these are mainly used in wines, dried foods, and potassium sorbate. It is an excellent preservative for the molds, yeasts, basically used in cheese, bakery products. So over here my correct option will be option number D, that is sodium benzoate. Question number 19. Which of the following combinations of analytical equipment property, measured and food property are correct? So first one, that is particle size analyzer, particle size distribution, span value. So this particle size analyzers, it will measure the particle size distribution, and the span value, it will quantify the distribution width. That means, for example, powdered foods. So option number A will be my correct option over here. Next, texture profile analyzer, morphology, chewiness. So this texture profile analyzer, it will measures the mechanical properties. Not the morphological property. Mechanical properties can be hardness, chewiness, which is assessed by the microscopy. So over here, this will be incorrect. Next, option number C, differential scanning, calorimeter, glass transition temperature, degree of caking. So this differential scanning colorimeter, it will measure the thermal transitions like the Tg values, which will affect the cake, which will affect in caking amorphous powders, say for example milk powders. So this is correct. Next, option number D, capillary viscometer, viscosity sensor. So capillary viscometers, they will measure the viscosity, but sensory properties, these are evaluated by human panels, not the instruments. So this is incorrect over here. So my correct answer is option number A and option number C. Mole percent of amino acid mixture present in glutenin of wheat gluten are glutamine and glutamic acid, serine and lysine, alanine and tryptophan, proline and glycine. So glutenin, it is a major It is a major protein in the wheat, gluten, and it is rich in glutamine and glutamic acid. Short form is GLN, GLU. So which together they will account approx 50% of its amino acid composition, and these amino acids they will contribute to the gluten's elasticity and the dose strength. Via hydrogen bonding and disulfide cross-linking. So this glutamine and glutamic acid, they will together account 50% of the amino acids, and these amino acids they will contribute to the gluten's elasticity as well as to the dose strength, and how to via hydrogen bonding and disulfide cross-linking. Whereas serine and lysine, these are not present. Actually, these are present but in lower amounts. Alanine and tryptophan, these are rare. And proline, glycine, so proline moderately high but not glycine. So over here, my correct option is option number A. The following compounds acts as an anti-nutritional factors: phytate, isoflavones, trypsin inhibitor, and resveratrol. So anti-nutritional factors, these are the compounds. They will interfere with the nutrients which is absorbed or utilized by our body. So phytate, it basically binds the minerals like iron, zinc, calcium, and it will reduce their bioavailability. Basically, these are found in the legumes. So it is an anti-nutritional compound. Whereas next isoflavones. So isoflavones, it is a phytoestrogen. We read about it. That is, for example, genestin. So it is a phytoestrogen, which will basically it will give benefits to our health. Uh, it is an antioxidant, anti-cancer, not an anti-nutritional compound. Next, trypsin inhibitor. So trypsin inhibitor, it will block the trypsin enzyme, and it will which will impair our protein digestions, and these are common in the raw soyas or legumes. So it is a anti-nutritional. It will block the trypsin enzyme. So this is an anti-nutritional compound. And next, that is resveratrol. So it is a polyphenol. Basically, it is found in grapes, and it have antioxidant or anti-inflammatory effects, and it has no negative impacts on our nutrient absorption. So over here my correct option is option number A and option number C. Whereas this anti-nutritional factors like this phytate or the lectins, they are beneficial like phytochemicals, with the for example say isoflavones or the resveratrol. So to reduce these anti-nutritional factors, the foods, they are soaked or they are fermented so that the we can reduce the phytate content in it. We can give heat treatments to it so that they will denature the trypsin inhibitors. So correct option over here is A and C. Brand is stabilized prior to oil extraction to protect it from the activity of, options are polyphenol oxidase, lipase, peroxidase or lipooxygenase. Now this rice bran, it contains some natural enzymes which can spoil its quality, it can reduce its oil yield if it is not been deactivated. So these lipase enzyme, it actually it plays a main role. Actually this enzyme is main concerned because it will break down the fats, that means the lipids, into the free fatty acids, which will cause us the rancidity or the off flavors. Now this will reduce even the nutritional and the economic values of the rice bran oil. That is why we have to stabilize this rice bran. Stabilization in the sense we will say like heat treatment, which will inactivate this lipase enzyme, which will prevent the quality of the, after inactivation it will prevent the quality of the oil. And without this stabilization, what will happen, this FFA level, it will rise rapidly, uh, which will make the oil unfit for consumption, since it will rancid, it will give some off flavors, that's why. Whereas this option number A, that is polyphenol oxidase, it causes browning, but it does not affect the quality. So it is mainly because main concern of this is browning reaction. And peroxidase is actually, it will affect the color, it might affect the flavor also of some plant tissues, but not the fat contents. And lipooxygenase, so it will oxidize the unsaturated fats. But over here this rice bran, over here they have asked about the primary one, so option number B over here, it will be correct option, lipase enzyme. In the postmortem degradation of muscle protein is trypsin, calpain, transglutaminase or pepsin. So basically when an animal is slaughtered, what will happen, its muscles will stop receiving the oxygen as well as the nutrients. Now this is when the postmortem changes it begins. Now, and over here, one very important change is the breakdown of the muscle protein, which will affect the meat's tenderness. Tenderness means how soft or how tough the meat it feels when we chew it. So over here, trypsin. So trypsin basically it is a digestive enzyme which is found in the small intestine, and it basically helps in digesting the protein in our body, and not in the postmortem of the muscle or breakdown. So this is a digestive enzyme. Calpain. So calpain, these are the calcium activated proteases, that means protein breakdown enzyme. Means when the animal is slaughtered, after its slaughter, the calcium ions, it will leak from the muscle cells, and then this will activate the calpain, now which will start the breakdown of the structural proteins in the muscles, like the jasmine or the titin, nebulins, etc. So this process basically it will soften the muscle tissues over time, leading to meat tenderization. So over here my correct option will be option number B, that is calpain. So calpain is the enzyme which is majorly involved in the postmortem degradation of the muscle protein. Let us discuss other two options also. So transglutaminase. So this enzyme actually it helps in cross-linking of the proteins. Means it is used in food industries as meat glue. And it does not help in the muscle degradation after the death of the animal. And pepsin. So pepsin, it is another type of digestive enzyme which is present in the stomachs, and it help and this will break down the protein during the digestion process. So over here my correct option will be option number B, that is calpain. Number 2. Which of the following is the correct pair of essential fatty acids? Oleic and linoleic acid, linoleic and linolenic acid, linoleic and lauric acid, linolenic and oleic acid. So fatty acids, these are the building blocks of fats. Now some of them our body can synthesize, whereas some of them our body cannot synthesize. Now those which we get from our diet, they are known as essential fatty acids. Now over here there are two essential fatty acids. First is linoleic acid, another is linolenic acid. Now linoleic acid, it is omega 6 fatty acid, and linolenic, it is omega 3 fatty acid. And these are crucial because of cell membrane structures or because of synthesis of hormones, brain developments, visions, maintaining skin health and all. The enzyme system used for removal of glucose from egg white prior to its drying. Options are glucose oxidase and catalase, glucosidase and glucoisomerase, glucoisomerase and catalase, glucoamylase and glucose oxidase. So basically egg white, they contain small amount of glucose. Egg white, small amount of glucose is present. Now if it is not removed, this glucose, what will happen? It will lead to the browning reaction, that is Maillard reaction, during the storage or the drying process. Even it will give off flavors to the product, which will hence reduce the shelf life as well as quality of the product. It will get reduced. So basically industries, they will use special type of enzymes to remove the glucose. Now first one, that is glucose oxidase. Now this glucose oxidase, it will convert the glucose to gluconic acid, and in this process what will happen, the oxygen is consumed and hydrogen peroxide will form, means glucose will give oxygen, so it will form gluconic acid. With this, hydrogen peroxide will be formed, and we know this hydrogen peroxide is harmful over here. But after using this catalyst, what will happen? It will break down this harmful hydrogen peroxide into oxygen and water and oxygen. So hydrogen peroxide into water and oxygen. Now this will prevent the hydrogen peroxide from damaging the proteins in the egg white. So together these two enzymes will remove the glucose safely without before the drying process. So my correct option is option number A, that is glucose oxidase and catalase. Whereas glucosidase, glucoisomerase, these are used for say carbohydrate modifications, and glucoisomerase catalase, these converts the glucose to fructose, and glucoamylase and glucose oxidase, these are for the hydrolysis of the starch. So over here my correct option is option number A. Extrusion, cooking, food materials are generally subjected to a combination of high shear, low pressure, high temperature, high shear, low shear, high temperature, or low shear, low pressure. So, extrusion of cooking is actually a high temperature, short time process. In the extruder, basically the food material, it has been compressed, then it is heated and sheared. So temperature can reach from 120 to 200 degrees Celsius also. And at this high temperature, mechanical shear, it comes from the from rotating the screws. So this combination, it gelatinizes the starch, it denatures the protein, it inactivates the enzyme, even it expands the product when it exits from the dye. So over here, high shear, low pressure is not low. So it's actually high inside the barrel. So option number A is wrong. High pressure, high temperature, high shear, it is the correct combination. And low shear, high temperature, so this is not, since shear is always high and shear is should be high. And the last one, that is low shear, low pressure, so both of them is wrong over here. So over here my correct option will be option number B, that is high temperature, high shear. This is the correct combination. Which among the given option truly depicts the lines 1 and 2 in the figure below with respect to the effect of heat processing on food? So first, x-axis is about the process severity, means it is telling us how intense the heat treatment is. Like if we'll use more heat, means more time, which will be equal to more severity. Whereas y-axis, it is about the value, means how much of something we have, like safety or quality. So line 1 is this is the curved line which is going up and leaving off. So means as the heat processing is increasing, our food safety is also increasing. Now as heat, it will kill the microorganism, the food will become more safer. Now after a point, what will happen? Safety will reach a maximum limit. After that you can't make food more safer. So our line 1 will be about the safety. Whereas line 2, it's going straight line, but it's going down. So as the heat processing is increasing, the quality of the food quality is now decreasing. Now too much heat, what will happen? It will destroy the quality of the foods, nutrients, color, flavor, texture, other things. So our second line, it depicts the quality. So in all, we can say our option number 1 is correct. Of paddy results into, so parboiling, basically it is a hydrothermal treatment of paddy. It is a hydrothermal treatment process of paddy. Basically, these steps it involves soaking, steaming, and drying process. Now, option number A, that is increasing in the milling loss. So, parboiling basically it reduces the milling loss, and even it the grain strength is improved over here. So option number A is incorrect. Option number B, that is increase in the nutritional value of the rice. So this is true because during soaking and steaming process, what happens, the vitamins and minerals from the bran layer it moves to the endosperm layer, and after milling only fewer nutrients are lost. So hence we can say that parboiled rice is nutritionally superior to the raw milled rice. Option number C, that is increase in the head rice recovery. So this statement is also true since steaming it gelatinizes the starch. Now grains they become harder and stronger. Now during milling less breakage occurs, so it results in more whole, that is head rice grains which are being obtained. So option number C is also correct. Now option number D, that is increase in the broken rice percentage. Now this is not at all true since it is opposite. Like parboiling it reduces the broken rice. So over here my correct option will be option number B and option number D. Sorry, C. Which among the following are omega-6 polyunsaturated essential fatty acids? So omega-6 fatty acids, we know they have the first double bond at the sixth carbon end from the sixth carbon from the methyl end, that is omega end. So they belong to the linoleic acid family, and they are important for cell membrane structure, for growth and development, for the synthesis of these icosanoids. So over here, my option number A, that is 18:2 linoleic acid. So this will be correct because parent fatty acid, it is actually a parent fatty acid of omega-6 family, and even it is an essential fatty acids. So this means that it cannot be synthesized by the human. So option number A is correct. Next, option number B, 18:3 alpha linolenic acid. So 18:3, so it belongs to the omega-3 family acids, not the omega-6 family acid. So over here the first double bond will be at the third carbon from the omega end. So it's uh, omega-3 fatty acid. So this option will not be correct. Next, option number C, 18:3 gamma linolenic acid. So it is, we know that it is a derivative of a linoleic acid. So we can say that it belongs to omega-6 series and it is important for our metabolic intermediates. So option number C is also correct. And option number D, that is 20:4 arachidonic acid. So it is a long chain omega-6 fatty acid which is synthesized from the linolenic acid. That means it is physiologically important for our health also. So we can say over here our correct option is option number A, option number C, and option number D. Which among the following statements are true with respect to the protein denaturation? So denaturation basically it means the loss of the native, that is the 3D structure of the protein. Basically it affects the secondary, tertiary, and the quaternary structure of the protein. So primary structure, we know it's a peptide bonds which remain intact. Now over here option number A, that is there may be an increase in the alpha helix and beta sheet structure, means during the denaturation the protein it unfolds and it rearranges. So in some cases what happens, new secondary structures, that is alpha helix or the beta sheet, it may form. So hence we can say that this statement is true. Next, it is a irreversible process. So no, denaturation is not always an irreversible process. So some protein it can renature from the normal conditions and they can be restored. So this statement is false. Next, option number C, that is when fully denatured, globular protein resembles a random coil. So this is true, since the fully denatured proteins, it lost their order structure. They behave like random flexible chains. So we can say that this statement is true. Next, the peptide bonds are broken. So peptide bonds, they belong to the primary structure. So denaturation does not break the peptide bonds. So breaking peptide bonds means hydrolysis. So it's not denaturation. So this is also not correct. So over here, my correct option will be option number A and option number C. The correct group of fat-soluble vitamins. So fat-soluble vitamins, we know what all are fat-soluble vitamins. Vitamin K, vitamin E, vitamin D and vitamin A. Best way to memorize is by kida, the word kida, insect. Whereas water soluble vitamins are vitamin B, means B complex, and vitamin C. So over here, cholecalciferol, so it is another name for vitamin D. Alpha tocopherol, another name for vitamin E. Menadion, it is another name for vitamin K. Thiamine, it's vitamin B1, so it is water soluble. Cholecalciferol, vitamin D. Alpha tocopherol, vitamin E. Niacin, so niacin we know it's vitamin B3. Alpha tocopherol, again it's fat soluble vitamin E. Menadion, it is vitamin K. Now biotin, so biotin, it is vitamin B7. Thiamine, it is vitamin B1, and niacin, it is vitamin B3. So over here, we can see the correct group of fat-soluble vitamin is option number A, that is cholecalciferol, alpha tocopherol, and menadion. So over here, my correct answer is option number A. The synthesis of thyroxine T4 in human body, it requires. Now thyroxine, it is a thyroid hormone. So it requires the hormones which are made using iodine. So over here, my first option, that is selenium. Basically, selenium, it helps in converting from T4 to T3. So it is not needed to make this T4 itself alone. So this is not correct. Next option number B. So this is my correct option also. So it's actually present as tetraiodothyronine. Tetra over here means T4. So it has 4 iodine atoms. So without iodine, we know that thyroid hormones cannot be made. Next option, iron. So iron is basically, it is used to make hemoglobins in the blood. And zinc, basically it helps in enzyme and immunity activities. So over here, my correct option will be option number B, that is iodine. Number 3, which among the following is not an essential amino acid? So we know that essential amino acids, they are they cannot be made by our body, so it must come from the food. Whereas non-essential amino acids, our body can make them. So over here, it is asking, it's not an essential amino acid. So L-phenylalanine, it is an essential amino acid. So it's an essential amino acid. L-valine, it is also an essential amino acid. L-lysine is also an essential amino acid, whereas L-arginine is not an essential amino acid. So it is not an essential amino acid. That means our body can make it. So it is conditionally essential, we can say, that it is basically needed in children or when a person is ill or is in stress. So over here, my correct option will be option number D, that is L-arginine. We have to find out that which statement is not correct. So codfish is a major source of omega-3 fatty acid. So yes, it is a good source of omega-3 fatty acid, good source of EPA, DHA. Beetroot is a good source for beta carotene. So it is a good source of beta carotene. Along with it, beta carotene, it is also found in, we can say, carrot, pumpkin. Even this beetroot, it contains a pigment called betalanine pigment. It is also important for your GATE exam purpose, that is betalanine. Now apple, it is a good source for vitamin B12. So no, it is not at all a good source of vitamin B12. It is a good source of vitamin C. So this statement is incorrect. Means over here our correct option will be option number C. Fresh sugar cane juice is a good source of polyphenol oxidase. So yes, fresh sugar cane juices, it's a good source of polyphenol oxidase. It is actually an enzyme which is present in this juice, and it is responsible for the browning reaction. So over here, my correct option will be option number C. Extrusion cooking is accomplished in 4 different stages, which is indicated as 1, 2, and 3, 4 in the figure given below, and we have to choose the correct option which is representing the name of the each stage. So first one we can see that it is straight. That means it is having low temperature and even low pressure is being given over here. So it's just we can say a beginning. So beginning means it is the feeding section or feeding zone. Next in stage 2, there's a certain increase in the temperature as well as the pressure. That means kneading or mixing has been started. Option number 3, that there's a drastic increase, so that means the highest temperature has been reached and the pressure is also highest over here. That means cooking is being done over here. And then there's a decrease in the temperature and the pressure. That means there's a sudden drop. That means pressure at the die which existence of the food product. So it's the expansion stage. So over here, my correct option will be option number C. That is, first is feeding zone, then kneading or mixing zone. Option number 3 is cooking zone, and then the expansion zone. So option number C is over here correct answer. We have to identify the correct statements which is related to the grain polysaccharides among the following. So first one, that is dextrins are a group of low molecular weight polysaccharides produced by a dry hydrolysis of starch. So yes, dextrins, they are formed when starch is partially broken, or it is broken by we can say by heat or by acid. So basically they are the short chain low molecular weight carbohydrate. So this statement is true. Next, amylose is a linear polymer of D-glucose units joined by alpha-1,6 glycoside linkage. So this is not true, since it is true that amylose is a linear polymer of D-glucose unit, but it is joined by 1,4 glycoside linkage. So this is incorrect statement. Next, amylopectin is a branched chain polymer of galactose monomer unit. So this is again incorrect, since amylopectin is made of D-glucose, not the galactose. Option number D, that is retrogradation, is a process of reassociation of amylose and formation of crystalline structure by gelatinized starch upon cooling.
So this statement is true since after gelatinization what happens? Starch changes, it realigns or realigns means it retrograde on cooling. So this process is known as retrogradation. So this statement is also correct over here. So option number A and option number D is my correct statement. Feeding studies, the weight gained in grams per gram of protein consumed by an animal is termed as what? First one, that is net protein ratio. So it is basically the weight gain of test group subtracted by the weight loss of non-protein group whole divided by protein intake. So basically it adjusts for the weight loss in a protein-free group. So this is not correct. Next, the net protein utilization, that is NPU, it is determined as retained nitrogen by nitrogen intake. By nitrogen intake into 100. So basically it is based on the, we can say, nitrogen balance, and not directly, it is based on the body weight gain. Next, that is coefficient of protein digestibility. So digestibility, basically it is determined as the nitrogen which has been absorbed by the nitrogen intake multiplied by 100. So it measures the absorption, not the growth. Third, last one, that is protein efficiency ratio. So it is the weight gain in gram per weight intake. The protein intake in gram. So over here, my correct option will be option number D, that is weight gain per protein intake. It is determined as protein efficiency ratio. Number 3, xerophthalmia is caused due to the deficiency of what? So xerophthalmia, it means that dryness in the eyes, night blindness, corneal damage. So these all, it is related to vitamin A deficiency. So over here correct option is option number C. Whereas thiamine, that is vitamin B1, it causes beriberi disease. Pantothenic acid, it is rarely deficient. Even it causes dermatitis, fatigue, and vitamin C, it causes scurvy. So over here my correct option is option number C. Following steps is used to remove phosphatides from crude oil in refining process. Now phosphatides, it means gum in the crude oil. So the refining step, specifically it means to remove the gums. Removal of gum, that process is known as degumming. Whereas neutralization, it removes the free fatty acid. free fatty acids. Bleaching, it removes the pigment. Degumming, it removes the gum or the phosphatides. And deodorization, it removes the odor from the oil. Or we can say volatile compounds. So over here, my correct option will be option number C, that is degumming. The unique flavor of chocolate and cocoa is due to the formation of what? So first option, that is 5-methyl 2-phenyl 2-hexanyl. So it basically provides a chocolatey, nutty floral, honey-like flavor, and it is basically found in chocolate, cocoa, baked goods. So over here, option number A is my correct option. Whereas cyclotine, it's a like maple-like caramel or nutty smoky taste. Furaniol, it's basically fruity caramel strawberry-like taste. And maltol, so it's a sweet caramel toasty cotton candy type tastes. So this maltol basically will find this in roasted malts, bread, coffee, and then furaniol in strawberries, or in, we can say, pineapples, basically used in beverage industries. So over here, my correct option is option number A, that is 5-methyl 2-phenyl 2-hexanyl. Following absorbents is not used as an ethylene absorber in active packaging of fruits and vegetables. First one, that is potassium permanganate. So basically it acts as an ethylene scavenger, and it oxidizes ethylene to carbon dioxide and water. Next, activated carbon. So it also absorbs ethylene gas because of its high surface area. Next, calcium hydroxide. So this is incorrect since it mainly uses CO2. It's actually a CO2 absorber. And silica gel. So it is also used as a carrier for potassium permanganate. So this is also true. So over here, my correct statement will be option number C. The processing of fluid milk at 72 degrees Celsius for 15 seconds is termed as high temperature short time HTST, LTLT, that is low temperature long time, ultra high temperature UHT, or homogenization process. Correct option is A, that is HTST. HTST, pasteurization process. So the purpose is to destroy the pathogenic bacteria while retaining the quality. Whereas for LTLT, the temperature is 63 degrees Celsius for 30 minutes. And for UHT, we can say it's around 135 to 150 degrees Celsius for just 1 to 2 seconds. Whereas homogenization, it's not a heat treatment, it's actually a mechanical process. So correct option is option number A. Following fatty acid are known to increase the low density lipoprotein, that is LDL cholesterol. First one, that is omega-3 fatty acid. So omega-3 fatty acid like EPA, DHA, or ALA, these all are found in the fish or the flax seeds. So they do not increase the LDL, mainly they lower the triglycerides, or we can say it can slightly increase or keep this LDL as neutral. Even it increases our HDL, which is the good cholesterol. So this is not responsible for rising the LDL. Next one, that is trans fatty acid. So yes, this is true since it is partially hydrogenated oils. So they basically increases the LDL, and LDL, it is a bad cholesterol. So it decreases our HDL, that means good cholesterol, and it increases the risks like cardiovascular risks. So this is true. Next, conjugated linoleic acid. Now, conjugated linoleic acid, it is basically found in the dairy fat or the ruminant meats. So their effects are mixed. So we can say that they do not consistently raise the LDL, but some of its isomers, we can say slightly it increases, or there is a decrease in its lipid. So this is also not true. Next, last one, that is saturated fatty acid. So example like palmitic acid or myristic, lauric acids found in butter or ghee, animal fat. So basically they increases our LDL cholesterol. It reduces the uh, HDL, that means our good cholesterol. So it is a major dietary which is caused by this high LDL. So over here our correct option will be option number B and option number D. Steps in food processing are used to reduce the acrylamide formation in food product. First one, that is pre-treatment using asparaginase enzyme. So this is true. Since this asparaginase enzyme, it will convert asparagine asparagine into aspartic acid and ammonia. Now this asparagine, it is a precursor for the acrylamide formation, and even it removes directly or reduces the acrylamide formation. Now it is widely used in potato chips, bakery products, so this is true. Next option, that is lowering the pH. So now acrylamide formation, is actually favored at neutral to alkaline pH. So it is neutral to alkaline pH. Means lowering the pH means more acidic. It suppresses, even means it will lead to Maillard pathway that forms acrylamide. And acid dips like citric acid, acetic acid in potatoes, it reduces the acrylamide. So this statement is also true. It increasing the temperature. This is not true since higher temperature, that means above say 120 degrees Celsius, it increases the Maillard reaction rate, and this leads to more acrylamide formation, so which is not at all accepted. Next, adding glucose. Glucose actually it is a reducing sugar, and it is one of the we can say main reactants with asparagine. Now adding glucose, it will increase the Maillard reaction, hence it will increase the acrylamide. So this statement is also not true. So correct statement is B and option number A. Which of the following enzyme is used for the production of high fructose syrup, that is HFS, from cornstarch? So first let us write the pathway, that is cornstarch to dextrin, dextrins to glucose, and glucose to fructose. First one, that is alpha amylase. Now this alpha amylase, it is used in the liquefaction step. That means it breaks starch, that is alpha 1,4 bonds into dextrins and oligosaccharides. So it is used in HFS production. Next, beta amylase. Beta amylase, basically it releases maltose unit from the starch end. Mainly it is used in brewing and malt production. So it's not a part of the standard industrial HFS process. Next, xylose isomerase, which is also called glucose isomerase. So basically this is the key step that makes high fructose syrup, that is essential for the, we can say it is an essential enzyme for HFS. Next, glucoamylase or amyloglucosidase. So basically it is used in saccharification step. That means it converts dextrins and maltose into free glucose, which is used. So over here our correct option will be option number A, option number C and option number D. Following contains the phytonutrient allicin. So over here, phytonutrients, we know that they are the natural compounds in plant that protect us from various diseases, illness, pests. They are having good anti-inflammatory property. They boost our immune systems. So over here, grape, it contains resveratrol, not allicin. So resveratrol. Cauliflower, it contains glucosinolates. Garlic, over here garlic will be our correct option, since garlic, it contains allin, and now this allin, when it has been crushed, so the enzymes which act on it, that is allinase enzyme, it converts it into allicin. This is an enzyme which on crushing will get allicin. Now this allicin, it is responsible for garlic smell, or they even it is a good, even it provides a good health benefit. Chili, so chili, it contains capsaicin. Which provides pungency like smell. So over here my correct option will be option number C, that is garlic. Following pigment does not have provitamin A activity. So our first option, that is beta carotene. So beta carotene has a strong provitamin A activity, since this can be cleaved in the body and it can form two molecules of vitamin A, that is retinol. Next, beta cryptoxanthin. So it also has a provitamin A activity, though less than this beta carotene, but it can be converted to vitamin A. Next, lycopene. So lycopene, it is an antioxidant. Mainly found in tomatoes. And so this cannot be converted to uh, vitamin A because it lacks beta iron ring structure. Next, alpha carotene. So alpha carotene also has a provitamin activity. Even this is also weaker than beta carotene, but it can be converted to vitamin A. So over here, my correct option will be option number C, that is lycopene. Identify the analysis that must be performed first to judge cleanliness of spice or herb powders. Cleanliness over here, it means basically it refers to the contamination with dirts, sands, or some other extraneous inorganic matter which is when picked up during harvesting or drying grinding process. So the first one, that is acid insoluble ash, measures actually the fraction of ash that does not dissolve in the acid. So this is largely, it represents like the silica, or we can say sand. So it is the first and the simplest test we can say, which judge the physical cleanliness. So our first option will be the correct option, since it indicates the presence of dirt, sand, silica matter, and directly it reflects to the cleanliness. Next one, that is pesticide residue levels. So it basically concerns the safety and chemical contamination, not the physical cleanliness. Next, volatile acid oil content. So it reflects the we can say color, the quality, sorry, the aroma, the quality, its authenticity, but not the cleanliness. And mycotoxin levels. So this basically reflects the fungal contaminations and safety, not the physical dirt or extraneous matter. So over here, my correct option will be option number A, that is acid insoluble ash content. Oil extraction, after bran is being separated from the brown rice, the quality of the rice bran oil it deteriorates. So we have to identify the cause and effect for the deterioration in the oil quality. So when the rice bran it has been separated from the brown rice, the oil which is present in the bran, it is suddenly exposed to the enzymes. Uh, Enzyme, that is lipase. Now we know that rice bran it naturally contains this rice bran, this lipase enzyme. So after milling, what happens? This lipase, when it comes in contact with the moisture, this lipase it hydrolyzes to triglycerides. Means it will break into free fatty acids and the glycerols. Now, the longer we can say the brand has been stored without the stabilization or the extraction process, the more lipase it will act on the oil. So more triglycerides will be broken down. So more free fatty acids will be there, like there will be increase in the free fatty acid content. So oil it becomes rancid, it will become more acidic, its quality will decrease. So over here my correct option, that is option number A, that lipase activity and the free fatty acid activity, both it will increase. Why? Because of the enzymatic hydrolysis, which will raise this free fatty acid and the glycerols, so it will deteriorate the quality of the oil. Next, that is oil hydrolysis and decrease in the free fatty acid. So no, there will be increase in the free fatty acids. Lipase content and decrease in free fatty acid, this is also incorrect. And brand stabilization decreases in lipase activity, this is also wrong, since we know that if stabilization is there, it will prevent the deterioration. So over here, my correct option will be option number A. That is, there will be increase in the free fatty acid content. Are the process that lead to the generation of new fats from the existing one. Means the chemically modification in which the original fat molecules which will modify to the new fat molecules. So first option, that is transesterification. So in transesterification, we know that the fatty acids, they are being rearranged among the triglycerides, and they produces new triglyceride structures with different melting points, with different structures, having different functionalities. So which is used to make especially the fats like margarine, cocoa butters. So this is the correct option. Next, degumming. So degumming, we know that it is a process of removal of phosphatides or the gums from the crude oil. So we can say basically it is a purification method. Here gums are removed from the crude oil. So no new fat has been created over here. Next, hydrogenation process. So in hydrogenation process, addition of hydrogen to the double bond of the unsaturated fats. So basically it converts this unsaturated fats to more saturated, or we can say partially saturated fats. So this will create new fat molecules with different physical properties, like having different melting points. So this is also correct option. Next, winterization process. So winterization process, it is actually the removal of, it is a process of removing high melting waxes or unsaturated fats by cooling or by filtration. So it is a separation process, we can say. Over here, waxes are removed. So my correct option will be option number A and option number C. Which of the following sequence of events occur during the formation of egg white? So over here, my Pn, it represents the native protein, Pd represents the denatured protein, Pa represents the aggregated protein, and Pg, it represents the protein gel. And this is the symbol for heating, and this is the symbol for cooling, and reversible sign is there, and a forward or irreversible sign is there in this options. So over here, first, what happens when the heating starts? That the native egg white protein unfolds. So this is initially a reversible process. So we can say that the native protein, which is a reversible process when heated, and forms a denatured protein. Now, if we will give more heat to it, so what will happen? It will start to aggregate. So denatured protein sticks together. So it will be a irreversible process. So upon more heating, it will start to aggregate. Now cooling will take place. That means gel formation will take place. So it will aggregate to form a 3D gel network. So this basically cools to form a 3D gel network. So over here, the correct sequence will be my option number B. So first the heating is Heating occurs, then denaturation, then further heating, aggregation will take place, then gel formation will take place. Suitable flexible packaging laminate for dry fruits. So laminate for dry fruits, it should protect from moisture, it should protect from the oxygen, it should have a good mechanical strength, it should be flexible. On top priority, it should be less costlier. Now, the first one, that is PET and LDP. So PET is a good one, but it is costlier and it is more rigid. So it is over designed for the simple dry fruits. So this PET will not be the correct option over here. Next, PS. So PS, it's a bit brittle in nature, so it's not flexible. So it cracks easily. It has poor moisture barrier property also. Next, BOPP. So BOPP, that is biaxial oriented polypropylene, it is a good it have a good moisture barrier property, it have a good clarity, transparency, it has a good we can say attractive appearance, its stiffness and strength is good, and over there good printability properties there. And LDP, so LDP, that is low density polyethylene, so it also acts as an excellent heat sealability property, it's flexible and it acts as a inner sealing layer. So over here the correct option, that is BOPP, because of its strength, appearance and moisture barrier, and LDP because of its sealing and flexibility. It will act as a perfect for my dry fruits, which must stay dry and crisp. Whereas this nylon, so nylon, it has a good oxygen barrier property, but it absorbs the moisture, and it's not ideal for dry fruits where moisture control is critical. So over here the correct option will be option number C. To identify the correct sequence of operations for dressing of the poultry. So first, in poultry, what happens? The bird is being killed and the blood is being drained out, means slaughtering process is done and bleeding is done. So bleeding is done because to improve the meat quality, its appearance. Then scalding means the bird is being dipped in the hot water, say approximately 50 to 60 degrees Celsius. Then it is basically done to loosen the feather follicles, to soften the skins. Next, defeathering is done to remove the feathers, and after that, evisceration, that means removal of the other internal organ is done, and this process is done later to prevent the contamination with the feathers. And at last, the carcass is being chilled so that to prevent the microbial growth and to maintain the quality. So over here my correct option would be option number A. Is are inhibitors of enzymatic browning in peeled potatoes. So enzymatic browning in peeled potatoes, it is due to the enzyme that is polyphenol oxidase. Enzyme that is PPO. Now this polyphenol oxidase enzyme, it requires oxygen, it requires phenolic substrates, and even it requires copper as cofactor. Now, first option, that is citric acid. So this citric acid, basically it will lower down the pH, and the polyphenol oxidase, it works better near to the neutral to acidic pH. So the acidity, it will slow it down. So it can chelate the copper to some extent. Thus this will inhibit the browning reaction. Next, EDTA. So EDTA, it is a strong chelating agent. So it will bind the copper ion, and which is required for our polyphenol oxidase activity. So we know that without copper, this polyphenol oxidase action cannot function. So it will act as a chelating agent. Next, mannitol. Now mannitol, it is a sugar alcohol. Means it is used as a sweetener, it is used as a humectant, so it does not inhibit the polyphenol oxidase or remove the oxygen or the copper. Next, ascorbic acid, so it is also a good reducing agent. Since it will convert this brown quinones back to the colorless phenols, and it also lowers the pH, so this will delay the browning reaction. So option number A, B and D will be my correct option. Hope you liked this session. Till then, thank you and enjoy learning.